Alright, welcome to the after work video. We're going a few minutes late. I did not switch right over to the after work video, but I think I'm good taking a 5-10 minute break between work and the after work video. That's not going to be a problem at all. The real problem would be actually skipping the after work video with such little time remaining. Okay, so last video we started setting up the L2VPN, and we actually finished all of the configuration. So this video is going to be more of a exciting video because it's just all verification steps, so there won't be a lot of dead time configuring stuff. So the first thing we're going to verify is provider Ospf adjacencies and route exchange. We're going to confirm the Ospf protocol is working properly in the provider network by verifying adjacency status and Ospf learned routes to the loopback addresses of the remote provider devices. Proper IGP operation is critical for the successful establishment of Mpls Lsps. Okay, so we're going to start on PE1, and we're going to verify the Ospf neighbor. It should just have one neighbor. Okay, we've got one neighbor and it's in stateful, so we've got no problems there. Let's do the next command where we verify the routes learned from Ospf. Now, this is interesting because, so we just want to verify that the loopback addresses are learned. If we're learning the loopback address, we're going to learn the other addresses pretty much. So I'm also using 192.168 for my loopback addresses, but I'm not using .0, .2, and 3. I'm using .1, .2, .1, .3, and then I've got more routers in my topology than they have, so I've got extra loopback addresses. But everything looks perfect. We've got different metrics. That depends on how close each one is. So this is going to be R8 because it's got a metric of 1. We know that it's the directly connected one here. And then we've got 2 more routers that are a metric of 2. And then we've got this far-reaching one. Router 6 here is a metric of 3. The output shows that the PE1 device has established an Ospf adjacency to the P device. It also shows that the P and remote PE device loopback addresses are learned via Ospf at the local PE device. Okay, so the next step is to verify Mpls and Rsvp interface settings. The purpose will be to verify that the Rsvp and Mpls protocols are configured to operate on the PE device's core-facing interfaces. This step also verifies that family Mpls is correctly configured at the unit level of the core-facing interfaces. So we're going to verify this on PE1 using the command show Mpls interface. Alright, and we've got one Mpls interface is in state up, so the next command we'll use will be verifying Rsvp. Now these are kind of out of order because you can't have Mpls working without Rsvp working, so I would have thought to verify Rsvp first, but we're just going with what's in the documentation. And we got good news here. It looks like it matches what they've got. One thing that I remember from the other topics on this exam is you can allocate bandwidth to these connections. So you can have an LSP that only allows usage of 10% of the bandwidth on certain links. and we went through the commands for that. I don't remember them directly off the top of my head, which might be a huge problem for me on test day. This is something I'm still kind of reconciling myself with. How much time should I be spending on stuff like I'm doing now, labs and hands-on, and how much time do I need to devote to just route memorization of things? And right now I'm currently devoting no time to route memorization of things because basically my reasoning is I just want to get as comfortable as I can on the device, on the CLI, and if I forget a thing or two, I can do help apropos, or I can do monitor, I can do trace option monitoring to try to just figure it out in real time. But that might be a losing strategy. Okay, so the output shows that Mpls and Rsvp are correctly configured on the local PE device's core facing and loopback interfaces. So next we're going to verify Rsvp signaled Lsps, and the reason we're going to do that is to verify that Rsvp sessions, ingress and egress, are properly established between the PE devices. We're going to have an extra session. They've only got 2 sessions. We're going to have 3 sessions when it works properly. But we can see right now we've got a problem here. We don't have Rsvp sessions working properly. So we're going to need to start here. We're going to need to do some troubleshooting. Okay. Huh. So I bet you my show Mpls LSP is down. Yeah, all my LSPs are of course down because I don't have Rsvp working. My interfaces are up. It's just I don't have any Rsvp sessions. But I do have an Rsvp neighbor. That's interesting. Why don't I have any Rsvp sessions? The output shows that both the ingress and egress Rsvp sessions are correctly established between the PE devices. Successful LSP establishment indicates the Mpls baseline is operational. Okay, so our Mpls baseline is not operational. I think it might have to do with the iBGP connection. Oh, no, it doesn't have to do with that because both of those are established. So, I wonder if family MPLS is missing from one of these. I think I've got a router where family MPLS is missing from one of the interfaces. Let's check that. That's kind of tricky to have those all enabled. That's gonna, little simple easy things like that can really trip you up. And this is why I'm spending so much time on the CLI, because it doesn't matter if I memorize that family MPLS is required on the interfaces if I'm not comfortable enough on the on the command line to even check that. Now the interesting thing is that both of those LSPs were down, so there is going to be an issue involving this path as well. But I'll just start by checking everything. Now I think maybe I didn't have Rsvp configured on anything. Maybe there were some where I only had LDP configured. Okay, so this is the low-hanging fruit as far as things that might be wrong, and it looks like there aren't any issues there. So the next thing I want to check is to see if Rsvp is configured. Oh, you know what? I know what the problem is. No, I know exactly what the problem is. It's weird. It's like not intuitive. It's like this is one of the main reasons I'm not spending so much time on memorizing, because like if I just memorize, like I won't. Well, actually, I don't know. The other, like if I can chunk in my memory, L2VPN configuration requires this, and just have it all memorized and say like, oh, well, that's missing. That would actually probably be better. So I'm going to think a lot about a memorization strategy. I used to use Anki. Like this would be the first test I've ever taken in my networking career where I did not use Anki in some way for some reason. And that scares me. Okay, so let me explain what I think the problem is. So I think the reason the Rsvp connections aren't able to come up is because if I do a show route 192.168.1.2, which is the so show configuration pipe display set pipe match LSP, yeah, which is the label switch path where that's pointed to. So the reason I don't have Rsvp is because if I do a show route on the endpoint for this, we can see it's in the inet.0 table. But to form a neighborship, I think it's got to be in more than just the inet.0 table. So what I'm saying is it's got to be sent through BGP and LRI. So I think we're missing a family. I think we need inet as well on everything. I mean, that's a really bold statement to make, though, because it's saying you don't need it. Yeah, it doesn't say that it's necessary. Well, it says this is what's required after you have the baseline in place. So the baseline might include that. Because let's go back and read about what is required for the baseline. Oh, okay. Yeah, see, that's what I thought. You don't need BGP for the baseline, right? Is this the baseline? Yeah, this is the baseline. Let's look at more information about what's required for the Mpls baseline, and specifically let's see if IBGP is required for an Mpls baseline. Okay, so they don't have BGP. IBGP is not required for a Mpls baseline. That's what I thought. Yeah, that's exactly what I thought. Huh, so what's missing? Yeah, so to troubleshoot our issues with the baseline config, we're only going to need to look at protocols Mpls, protocols Rsvp, protocols Ospf, and then of course the IP addressing. So maybe there's a IP addressing issue, but I did have all of the I'm not missing any OSPF routes. Why is there not? I'm really confused why there's no Rsvp session. Maybe there's one between these two routers, but for some reason one didn't make it to that one. Okay, yeah, so that happened. So it looks like we're good there, but there's an issue here. Huh. That's interesting. So to here, everything is good, perfect, but to here, there's problems. So let's check the connection here. Okay, so, oh, actually it's going to be 2 is the one that's facing this. So we've got 10.1.1.2/30, 10.1.1.1/30, family Mpls. Okay, let's take a look at the Rsvp. Yeah. Huh. That makes no sense at all. Why is it good? Why is it good there, but it's not good here? Maybe it's got to be something like on here. It's got to be a problem with this like actual PE. Maybe because I'm missing. You know what? It's probably because I'm missing LO0 from this. So let's do all right, let's just do yeah, protocols Mpls. Okay, and then let's compare. Oh, but it doesn't have to have the loopback for the P routers, but the PE routers have to have all the loopbacks, because otherwise the endpoints of the Lsps won't be able to communicate with each other. But on the P routers you don't need the loopbacks, because you're not actually using any of those addresses as a endpoint. Oh, okay, that's interesting. There goes that theory. Out the water. Alright, well maybe I forgot it for Rsvp. Yeah, because we have the loopbacks in here for Rsvp. So maybe it's missing. Nope. What about Ospf? I might be missing it. Although we did see it was showing. Oh, but we only checked this one. We didn't check the other sides. Okay, I've got it. Aha, I found it. So the issue is we're missing Ospf traffic engineering from this one. So if I would do a show Mpls LSP detail, I should be able to see, oh wait, LSP, or show Rsvp session detail. I forget what command this was. There was a command where I could see like a lot of important stuff. Name. Okay, yeah. Wait, where's that command I was looking for? I forget what command that was. Session? Was it session or interface? There's only TD database. Yeah, and you can see we don't even have a, so this is a dead giveaway right here because we don't even have a TED database enabled. So that's really the only command I need to be extra sure that is yeah. Yeah, the other thing I wanna do before I do this is so we've got that issue with Rsvp neighbors, so I want to enable some trace options on there and kind of see how it looks when it's messed up. Okay, so then let's do a monitor start and see what we're getting, and then we'll fix the problem with those on there and hopefully learn some more about how this works. Or at the very least, how it's going to look on the test. But this is another reason why I'm kind of focusing more on hands-on than memorization, because I just don't think it's practical for me to log into every router, look at the configuration, and just have memorized what's required on there, because you know I'm not going to know if there's some special knob required, or like it's going to throw me for a loop. It to me seems like the hard way. It seems like it's much easier to just be so incredibly confident on the command line that I can just look at, you know, the biggest garbage in the world and know right away what's going on. Okay, so here's some messages pertaining to it being broken. Well, it's not specifically about it being broken, but let's see what happens when I fix it. We should get a flood of messages. Yep. Okay, now we're looking good. Cool. Looks good to me. Oh, we got more stuff. Now we're getting like hellos and stuff since it's actually like up. So we're going to get a lot of information about that, but we don't need to see that. I mean, I guess we can see like what label it's going to use. All the steps we'll look into later. We'll just show up there, I think. But yeah, let's go back to the steps and we can rerun the step from before. Let's jump down and do the verification. Here we go. So yeah, we're going to verify Rsvp signal Lsps through show SVP session. Okay, so they are absolutely up. The output shows that the ingress and egress Rsvp sessions are correctly established between the CE devices. Successful LSP establishment indicates the Mpls baseline is operational. So next we're going to be verifying BGP session status, and we're going to do this because we're going to verify that the BGP session between the PE devices is correctly established with support for layer 2 VPN network layer reachability information. So the NLRI that is supported shows up in this command BGP summary. It's listed underneath the neighbor. So we've got two neighbors, and we've got two kinds of NLRI. We've got one that's just the generic L2VPN. Well, I mean, one thing that's important to remember is that command family L2VPN signaling. Let's print that out. Yeah, this actually enables more than just one NLRI. It allows NLRI for, let's look that up, help apropos match help topic match. But it allows NLRI for L2 VPNs and for L2 circuits. So maybe this is it? Let's try family. Yeah, BGP family. So multi-protocol BGP, MPBGP is an extension of BGP that enables BGP to carry routing information for multiple network layers and address families. MPBGP can carry the unicast routes used for multicast routing separately from the routes used for unicast IP forwarding. To enable MPBGP, you configure BGP to carry network layer reachability information NLRI for address families other than unicast IPv4 by including the family INET statements. To enable, okay, so it's going to describe each one. So here's the L2VPN. NLRI, it's going to be family INET.-VPN. Oh, that's good to know, actually, because I actually didn't know that. Oh, well, it's evident because INET means layer 3. So okay, so that's makes it a lot easier for me to understand now. Yeah, so this is pretty good documentation here. And see, this is the thing. Like, if I spent more time on just route memorization, like, I wouldn't have dug into this help apropos as much, and this is going to be a lot more valuable to me to be able to work something out on the fly and figure it out in real time than to just have it memorized and oops if it's different than how I memorized it, or if I forget a key detail, or if what I have memorized is just so divorced from what I'm actually going to see on test day that it doesn't really do me any good, and that's going to be a big problem. So I'm still like pretty uncertain about my current test strategies, but we'll see. We will see. Okay, so unfortunately they don't have any information about the L2VPN signaling one, the one I wanted to look up. So again, I'm left high and dry by this documentation. Seems to be a common theme, but at least I got something. It's kind of like you're in the hospital for some pain thing, and the nurse gives you a button you push, and the button doesn't do anything. You get to push the button, and it's psychological. I don't think they actually do that. I'm sure the button actually does give you a dose of whatever medicine. But yeah, okay, so show summary, let's do that one more time. the output shows the BGP session to the remote PE device, in our case we're going to have 2 of them, has been correctly established. And through the up-down field, how long the session has been in the current state. So let's see how long it's been in the current state. Here we go, for a long time. Like an hour? That seem right? That doesn't seem right. Is that seconds or minutes? Wow, okay. I don't know how it's been up for like an hour. Because I just... Oh, you know what? Because I configured it during the lunch break. So that actually seems to not be long enough if it's been up since lunch. It also shows the number of BGP packets sent to and received from the remote PE device. Let's take a look at that. Ah, okay, so quite a few. The flaps field confirms that no state transitions has occurred. Okay. Indicating the session is stable. Also note that L2VPN NLRI is correctly exchanged between the PE devices. This output confirms the BGP peering between the PE devices is ready to support a layer 2 VPN. Okay, so we're good to go. We're ready to support that layer 2 VPN. That's a really good tip. If I've got a problem on the test and I see this flaps coming up, that might be something I have to resolve. I have no idea how to resolve a flapping BGP neighborship. I guess what I could do is help apropos. I match flap. Oh, so yeah, this would actually help me a lot because it could be like an authentication problem, could be a problem with BFD. So I can check like the authentication of BFD. I can check the hold down intervals, all that. I can check so damping. It could be a problem with. Yeah, so this help apropos is actually like really helpful. I know damping is going to be on the test. Oh, well, actually I don't know that it's going to be on the test, but damping is in the curriculum from what I understand. Yeah. It's cool. Yeah, this whole thing. And this is 17, not 19, which I'll get on the exam, but I'm hoping that if it's in 17, not only is it going to be in 19 as well, it's actually going to be a little bit better in 19. Okay, so before I move on to verifying layer 2 VPN routes in the routing table, I'm going to take a quick break. I'll be right back. Okay, back. So let's continue on with the verification steps. We're going to go on PE1 and we're going to verify that the routing table on the PE1 device is populated with the layer 2 VPN routes used to forward traffic between the CE devices. So we should have MAC addresses too. I'm just confused that these are layer 2 VPN routes because I layer 2 routes, like that sounds like a MAC address to me. But let's see here. Show route table p.l2vpn.0. Aha, but we've got them. Perfect. Looks good to me. /96s. We've got a IP address :12:2:3. So I think what these correspond to. Let's do a show configuration. Routing instances. No more. So we've got our site identifier, which is, oh, does it correspond to the site identifier? Oh, okay, so this is just straight up the route distinguisher here. Oh, no, it's not. Oh, no, it is, but it's the route distinguisher from the other side. So if we were to log on to the other ones and do the same command, we would see this route distinguisher here. Let's try that just to make extra super sure. Yeah, so here's the route distinguisher from router 4. Yep, defined here, 192.168.1.1:12, 192.168.1.1:12, perfect. Okay, so now, this is what I thought. So now this is going to be the site identifier. So an L2 route is the route distinguisher, followed by the site identifier, followed by, I don't know what this number 3 is for. Oh, followed by the remote site ID. And you can probably, leave this out and it'll automatically fill that in. But yeah, so the remote site ID should be 1 on R6. Oh, that's interesting. The remote site ID is 2. Okay, so what is this last number? Yeah, I'm not sure. Let's check the next routing table. So that was the BGP routing table. So let's check the routing instance routing table. Okay, so we've got the same things, but now we've got our directly connected one. The command show route table bgp.l2vpn.0 displays all layer 2 VPN routes that have been received on the PE device. The command show route table L2VPN1.l2vpn.0 shows the layer 2 VPN routes that have been imported into the L2VPN1 routing instance as a result of a matching route target. The L2VPN1.l2vpn.0 table contains both the local PE device's layer 2 VPN route as well as a remote route learned via the BGP peering to the remote PE device. Both tables show the remote layer 2 VPN route is correctly associated with the LSP to PE LSP as a forwarding next hop. Yep. Oops, I'm getting a call. This is probably a scam call from Wisconsin. Yeah, I don't recognize the number, and I get a lot of scam calls from Wisconsin, so that's not a real call. Okay, so let's see here. So the outputs confirm that the local PE device has learned about the remote customer site from the PE2 device. It also shows that it can forward layer 2 VPN traffic to the PE2 device using Mpls transport over the provider network. Okay, so now here's the big moment of truth. Show L2VPN connections. This is something I could not get to work in the last in the last one. Boom, but we got it to work this time. So what the heck was I missing in the last one? That's what I'm confused about. Oh, you know what? Maybe I was missing traffic engineering, just like I was here. Where my site identifiers and my remote site IDs were all off. I have no idea. I kind of wish I could go back, but I can't. I mean, the good news is it's working now. But I have a feeling I'm going to sit down during the test and see what I saw in the last one and not be able to figure it out. But cool, yeah, so it's in state CN now, which stands for circuit not provisioned. Ah, that's right, because even though it's, I remember that, so. Oh, you know what, it's in, oh no, it isn't up. Okay, so it looks like we've actually got some problems here between, to the connection site 2. That we'll need to resolve. Which isn't the worst thing in the world. Yeah, I'd actually rather have it that way because now I can actually do some troubleshooting. Okay, I should have a trace options file. Yeah. So why is one of them working but the other is not? And which one is working and which one is not working? Oh, okay, so it looks like we've got a log message. So we've got an MTU mismatch. And that's associated with site CE1, but it looks like it passed, so I don't know what that means. I don't know why that popped up there. Is there an MTU mismatch? I didn't think I changed my MTU settings, so they should all be default. See, and this is the sort of thing too that I can't, like being really comfortable on the command line like this, which I really feel like I am, is not something I get from just memorizing stuff. So I'm just trying to justify in my mind the fact that I'm not using Anki and doing the same things I did for my previous exams, but it's because this is a completely different exam, no multiple choice, all hands-on. That's why my study is so different. Okay, so it looks like this one is up, but the other one is down. Okay, so the connection to remote PE 1.3 is up, but the connection to 1.2 is in state CN, which means circuit not provisioned. Which is interesting because we've got a local site. Oh, you know what? Okay, I understand the site IDs now. Okay, I understand how this works. I didn't understand this before. So let's do pipe match site. Okay, so now what we have is we have a local site identifier for each of these PEs. So this one gets 1, this one gets 2, and this one gets 3. So we're going to need to set up a remote site identifier in the same way we did for our LSPs. So let's look at our LSPs again. Yeah, so now you can see my loopback here is .3, so I've got an LSP to .1, .2. Same thing on all the other devices. I'm .2, so I've got 1.3. I'm .1, so I've got .2.3. So that exact same type of configuration is also required for the remote site IDs. Unless there's a way to automatically have them discover it or something like that, but we're going to need remote site ID 2 added to here, 1 added to here, and 1 added to here. So let's do that. And the reason we're adding those is because those are what are defined here. So just like here, where we're using loopback addresses, we're doing that same type of configuration, but we're using site identifiers. Cool. Yeah, I think that's probably exactly why it was messing up before. Well, lots of reasons, but I'm really happy with the work I'm doing right now. I'm feeling better. I'm feeling good about this test, and if I can put together an Anki to maybe just memorize, so like I can say like L2VPN, what configurations does it require? You know, just boom, boom, boom. All these concepts just have the configuration pop into my brain. That might be really valuable. I can do that. I have enough time to do that. It takes like a few weeks, but I'd have to start. I'd have to finish it by the end of this week if I wanted to get good use out of Anki. Okay, so we see change to up already. Can do a monitor stop, show L2 circuit connections. Oops, it's not an L2 circuit, it's an L2VPN. Oops, so now we've got a bit of a problem here. We've got OR, which is circuit out of range. And that's what we had before, but the interesting thing about that is we had that for 3, but now we have 2 looks good, but now 3's having issues. Oh, okay, because I got rid of that. So did it just overwrite it? It kind of looks like it just overwrote it, and I wasn't able to have 2 of them. Yeah, so it overwrites it. I'm not able to have 2 of them. Okay, so much for that theory. What the heck happened? Do I need more than one interface? Which interface is meant to be? I'm just confused. Okay, local interface, they're using this interface. Now is that the customer facing interface? Yeah, that's the PE interface, that's what I thought. That makes no sense. Oh no, it makes perfect sense, but I don't understand how I can add more than one remote site. And I don't understand why they wouldn't think that was necessary. Oh, you know what? I think I would need. Yeah, I think you can only have one remote site per interface. Yeah, you have to have because it's basically just a wire. So like, you can't have more than just a point-to-point. I think I have no idea. I mean, what if I just get rid of that command? What if I just do delete remote site ID? I think what happens with that is it'll just automatically form a connection, but I'm pretty sure it will just it'll automatically only form a single connection. Like, I think for each connection you have to have your own interface. Yeah, because we can see now what's happening is it's automatically forming it, but it's only able to automatically form it to 1 because this interface is used up. So it's forming point-to-point connections. Yeah, so this one won't have any connections at all. Yeah. But what I can do is add more interfaces and then create more connections that way. So let's try that. Okay, so we're going to create another interface. Okay, and then we're going to add that other interface to the L2VPN. Oh, right, but we're going to need to add it to the straight up routing instance as well, not just protocols L2VPN. It's got to belong to the routing instance before we can bring it into protocols L2VPN within the routing instance. Okay, but that should do it, so okay.
Oh, I don't know where this 3 came from. Oh, I see. I tried to... I made a mistake in changing the name for the site. Perfect. So hopefully now we'll have an extra L2VPN connection. We do. Oh, but one of them's down. Why is that one down? Is it waiting for the mismatch? Check. Maybe now that the mismatch check has passed, it's gonna go. I don't understand why it's down. Oh, because I think it's because the interface is down. Yeah, like I bet you if I take a Cisco and I plug it in, that'll go up. Yeah, I guarantee you that will happen. Okay, but it's populated, everything looks great. It's just the port is not up, it's not plugged into anything. So yeah, let's just do that quick. We're gonna plug it into Cisco and hopefully see that come up. Let's try to get as many trace options going as we can. So let's get the edit protocols, Rsvp, trace options, file, Rsvp, flag all, what else do I think will be interesting? I guess the actual port might be interesting as well. Oh, why can't I specify a file for this one? I don't understand why I can't specify a file for this one. Okay, so we've got a bunch of trace options set up now. Lots of stuff. Now this is just the L2VPN. I wish they would tell me which file, like over here, say like which file is outputting all of this. But this seems pretty clear to be, yeah. Okay, so let's monitor Rsvp. Monitor start Rsvp, monitor start Mpls. Okay, and then let's go ahead and plug that in. How am I gonna do this? Yeah, right. Okay, and then I need a Cisco.
Okay, boot up the Cisco. 022. Okay, yep, and there we go. It's already going crazy. There we go. So now we're in state up because the port is up. So yeah, this was a lot easier than I thought it would be. This video is just going on an hour now, but I think that's enough. I feel pretty confident. I feel like I really understand what that remote site command means a lot better. It's basically what the thing that kind of confused me is I thought they would all just go and discover each other and each interface was a point to multi-point interface, but it turns out that each is a point-to-point interface, and you can specify which other point you wanted to go with, or it can just automatically pick one. But if you don't have enough interfaces, you won't enough interfaces for each point in your L2VPN. You won't have some points come up. It's not. It doesn't work. It doesn't work the same way as like a routing table where it will like pass it to all the routers. It will run out of connections after it has formed a single connection because it's just point to point. So if I have but what I can do is create VLANs with more connections. I can add another port to it. Lots of things I can do to increase the amount of nodes that belong to my L2VPN. Okay, so that's going to be it for L2VPN. So mark that as done. And I already did EVPN before. I've got some real-world experience in that. I got some training, on-the-job training in that. So I'm pretty confident in that, and I already did this a while ago. So I'm feeling good about that. So that's going to be it for L2VPNs. So yeah, I'm feeling good. Okay, so the next video we're gonna. So I'm done with the whole VPNs topic. So that's really good news. We've got the exam coming up in just less than about 20 days. I've been, and then let's see how many topics we've got left. We've got 1, 2, 3, 4, and we've got 5, 6, 7, 8, 9. So I should be able to get through everything, and not only that, I should have some extra time to do some stuff. I do have some in my notes here. I've got some free workbooks that I found through Googling. So it's just some demos of some scenarios. So I could just pull up these free. You can see that there's a watermark on there saying that it's a free demo version. So I can pull that up and just try to do the scenarios they have there. So the test is going to look something like this. It's going to be it's going to meant to look very intimidating and to confuse me and all this. Oh man. So yeah, I can look at this because here they have a set of 13 steps to follow. So I can try to follow all those steps. They've also got yep. So that's not the only one. I've also got a official study guide that might have some examples in it, so I can go through those. And then I've got more free iNet Zero workbooks, demo workbooks that I can go through. Yeah, content only available in original. So this is just a free demo. Yeah, you actually can't pay for this anymore because Juniper offers official study material, which I want, but it's like last time I checked, they were charging like $2,000 for it, which is like not reasonable. I think they might have dropped it down to 600, but I kind of wanted to just see if I could use their official documentation, and then a lot of that official documentation I've been using is the help apropos documentation. It's the same thing, so I can use it during the exam. But you can see here, you know, a good outline of what the test is going to be. When I sit down, they're going to have general system features I'm going to need to configure. They're going to have troubleshooting command, so I can kind of give myself a little bit of a and they've got a full day challenge here. So but basically this looks like what it's going to be on test day. I'm going to be building the initial system configuration. I'm going to be building the network, IGP, BGP, Mpls, VPN, class of service. So yeah, it should be good. I'm feeling okay. I think I'm going to get through all the material, which was a big kind of stress point for me. I just thought I wasn't going to get through studying all the material. But yeah, that's a big relief, big thing off my chest. I am still worried about not using Anki, not using memorization the way I had in the past, but it's a different kind of test. One thing I might want to, yeah. So I think I've got a good plan. We're just gonna plow through this, try to do at least one topic a day. The earlier I can finish, the better, though, because I think after I'm done with that, we're going to go through these free workbooks I found, and then I'm just going to try to do my own scenarios. So I'm going to make sure I can do all of this, make sure I can do SNMP configuration, firewall filters, all of this just down the pipe, and then this is. Yeah, so I think I've got a good plan. So thanks for coming along. Still got a lot to get through. So let's keep going, keep the pace as intense as I possibly can. Because if I get to test day and it's like, oh, if I just studied this for an extra 5 minutes, I would have passed. Definitely don't want that scenario. So thanks for watching, and I'll see you in the next one.